The function defined by d equals 50 plus 312t minus 16t squared gives the height in feet of a cannonball t seconds after the ball leaves a cannon. Remember that the equation has the negative 16t squared to represent the effect of gravity. The constant term is the initial height from which the cannonball was fired, and v naught t represents the distance based on the initial vertical velocity. What does the term 50 tell us about the cannonball? Since 50 is the constant value, it tells us that the cannonball was initially fired from a height 50 feet above the ground. What does the term 312t tell us about the cannonball? 312t tells us that the initial upward velocity of the cannonball was 312 feet per second. What does the shape of the graph for this scenario tell us about the movement of the cannonball? Since the graph is first increasing and then decreasing, that tells us that the cannonball initially rises and then falls to the ground. The peak of the graph, also called the vertex, is the maximum height of the cannonball. The cannonball's maximum height occurs 10 seconds after it's fired and is just over 1,500 feet. Could the graph be used to approximate when the cannonball hits the ground? Yes. The graph shows that the height is 0 right before the time is 20 seconds. This point is a 0 of the graph. Zeros occur at x values where the function is equal to 0 or where the function meets the x-axis. Notice that the cannonball is launched from a height of 50 feet, so the other 0 for this function would be when t is negative. This other 0 isn't particularly helpful for our situation. If the cannonball were fired with a vertical velocity of 800 feet per second, would it reach a mile in height? First, we need to adjust our equation to represent the new initial velocity. The maximum height seems to be at around 25 seconds. So we need to substitute 25 into our new formula, and the result is a maximum height of 10,050 feet. There are 5,280 feet in a mile, so the maximum height of this cannonball is much greater than a mile.